Hello, welcome to RF Insights. In this short video, I want to go through the concept of spectrum sharing. As you might know, if you look at the frequency allocation tables from ITUR or from the country that you live in, you will see that different services could operate at the same band or at the adjacent band. For example, looking at this table, at 18.6 to 18.8 gigahertz, we have all these services operating together: Earth exploration satellite, fixed satellite, mobile, and space research. Furthermore, we have services in the adjacent bands, 18.8 to 19.3, as well as on the lower band, there are other services operating too. So as you will see in this video, we have multiple issues here. One of the important issues is the inter-system interference and intra-system interference. Intra-system interference refers to interference between adjacent channels within the same service. For example, if this is a 5G service or mobile service, each channel can interfere with the channel adjacent to it. So there are various ways to mitigate this kind of inter-system interference in each service. And if we have another service co-primary with the service A, let's call it service B, there is also this possibility of interference between these two totally separate services. So spectrum managers and regulators in each country, one of their goals is to allow the systems operate in adjacent bands or in the same band, but mitigate the possibility of interference between these services. For the adjacent band interference, it is normally caused by out-of-band emissions or spurious emissions of a service. These limits of out-of-band emissions and spurious emissions are defined in Article 1 of the ITUR, as well as in recommendation SM 1541 and SM 329. In summary, if this line here is the end of the desired bandwidths of a service, anything that falls outside of this would be called unwanted emissions. So anything outside of the assigned bandwidths to a service is called unwanted emissions. But this unwanted emissions normally is divided into two separate categories. One of them is the out-of-band emissions and the other one is the spurious emissions. So out-of-band emissions starts immediately after the necessary bandwidth finishes and goes up to 2.5 times of the bandwidth of the service, right? And anything after 2.5 times of the bandwidth is called spurious emissions. So these are unwanted emissions. So the goal is to reduce these emissions as much as possible, but it is not possible to totally remove or eliminate these kind of emissions in radio systems because of different reasons, harmonics or leaks in the system. This figure here, for example, shows you the carrier, the shape of a carrier of a 80 megahertz 3GPP carrier. It's 80 megahertz. That means the desired signal bandwidth is from -40 to 40. This is frequency offset, right? This is not the actual frequency, but it is frequency offset from the center frequency of the signal. Then anything after 40 megahertz to 200 megahertz, which is 2.5 times of 80 megahertz, is called out-of-band emissions, and anything further than 200 megahertz falls within the spurious domain. So this out-of-band emission and these spurious emissions are the emissions that cause adjacent channel interference with other services that may operate in adjacent channels. And there are different ways of mitigating these kind of interferences. I'm not going to go through them in this video because it's going to be too long, but I'm going to make another video to explain what those mitigation measures would be. So in summary, if we want to categorize types of interference in a shared spectrum, we can have co-channel interference when both systems operate on the same band, or we can have adjacent channel interference. Adjacent channel interference on its own could be divided into two categories: out-of-band emissions and receiver blocking. So these out-of-band emissions can be caused both by out-of-band emission interference could be caused by both out-of-band emissions and spurious emissions, but receiver blocking is not really does not have anything to do with the out-of-band emissions. This receiver blocking is caused by high power by high power emissions from one service entering the receiver of the other service, just because of the fact that the receiver is not properly isolated or filtered properly. This can cause issues for a lot of cases. For example, this is the actual frequency allocation in many countries, including Canada. So we have 3900 to 3980 is assigned to fixed or mobile service in a non-competitive licensing group, or NCL. And then we have a 20 megahertz guard band between this mobile service with the adjacent band service, which is a fixed satellite service, which expands from 4 gigahertz to 4.2 gigahertz. And then we have aeronautical service beyond 4200 megahertz. In order to this service not to cause interference into fixed satellite service, as I said, we have two kind of interferences: out-of-band emissions and receiver blocking. In order to avoid the out-of-band emissions to cause interference in this service, we have put 20 megahertz guard band here. So this 20 megahertz guard band can kind of reduce the effect of out-of-band emission to some extent, but sometimes it's not enough. So other than that, we can define other measures like a minimum distance between these two services. So that means if any mobile or fixed station is going to be deployed somewhere, it has to make sure that it is not closer than a minimum distance to a fixed satellite service station. And there is the issue of receiver blocking, because these transmitters or base stations in the 5G are pretty powerful. They can cause the fixed satellite service station saturate very easily. Therefore, we ask fixed satellite service receivers to install some kind of high pass filter in order to block the high power emissions from the fixed or mobile services. If you look at the fixed mobile service and its relation with respect to aeronautical service, you can see there is a 220 megahertz separation between these two services. But still, if you know, I'm not sure if you know or not, but there was a lot of controversy surrounding the introduction of this service in this band and the impact on the aeronautical services, specifically on the radio altimeters. And some studies show that even though these two services are 220 megahertz apart, still this 5G stations can saturate the receiver of these aeronautical radars and cause some fatal errors on the airplanes. It could be life-threatening. Therefore, the studies suggested that there must be some kind of exclusion zones around the airports, that 5G towers are not allowed to operate, as well as these aeronautical services need to install a high-pass filter on their radio altimeter receiver side in order to block the high-power emissions from the fixed or mobile services. That's it for today. This was an introductory video on this subject. I'll try to add more videos to expand more on these subjects. Please don't forget to like and subscribe to the channel. Leave a comment if you have any questions on these subjects. I will be glad to answer them. So please ask me any questions you want. Thank you very much for your attention, and I wish you a very good time. Thank you.